Thank you for watching. My name is Astrid Krasniqi. Today we are covering CCNA Semester 2, Chapter 3, VLANs. Objectives for this lesson is to explain the purpose of VLANs in a switch network, analyze how a switch forwards frames based on the VLAN configuration in a multi-switched environment, configure a switch port to be assigned to VLAN based on the requirement, configure a trunk port on a LAN switch, configure a dynamic trunking protocol DTP, and troubleshoot VLAN and trunk configuration in a switch network. VLAN definitions. A VLAN is a logical partition of layer 2 network. Here I have a network of 8 PCs connected to 2 switches. These PCs, they will be able to communicate with each other without a problem because they all belong to the same VLAN, VLAN 1, which is the default VLAN. Now here I have 8 PCs, but it could be 80 or 800 PCs. It's the same. So if one PC sends a message, they will be able to communicate with every other PCs on the network. So for example, if one broadcast goes to the switch is going to flood that broadcast. It's going to send it to every port apart from the port they came in on. So it's going to flood the broadcast, which means every PC on the network will hear that broadcast message. This might be the case on the very small networks, it's okay, but if in large networks this could be a big problem. Another problem that we can solve is security. You don't want all the PCs to be on the same VLAN. For example, you have some PCs here on IT, some PCs on management, finance, and all that. You don't want all the PCs to be on the same VLAN. So we separate them on the virtual local area networks, VLANs. So for example, here we have created the blue VLAN. We got these 2 PCs on the blue VLAN. Then red VLAN, we have this PC on the red VLAN. Then we have the green VLAN, this PC on the green VLAN, and the same on the switch here. So now inter-VLAN communication cannot happen on this network, because to have an inter-VLAN communication we need a layer 3 device like a router and so on. So all the communication here will happen between the blue VLAN PCs on this switch and on this switch here as well, the blue VLAN PCs. So between blue VLAN and red VLAN there's no communication. So if the broadcast comes from the blue VLAN, red VLAN and green VLAN PCs, they're not going to hear that broadcast. So imagine that's a broadcast message. As soon as it goes to the switch will flood it to every port apart from the port they came in on, but every port that belongs to that same VLAN. So in this case it has sent it to blue VLAN PC on this switch, send it through the trunk to the second switch, and the second switch has forwarded to the blue VLAN PCs only. Same will go for the red VLAN PC. If the red VLAN PC sends a broadcast message, it will go only to the red VLAN PCs. So VLANs is a logical separation of a local area network. So VLAN is a logical partition of a layer 2 network. Multiple partition can be created. So like we had blue VLAN, red VLAN, green VLAN, we can create as many partitions as we want, allowing for multiple VLANs to coexist. Each VLAN is a broadcast domain, usually with its own IP address. Like we said, if we send a broadcast message, only the PCs that belong to that VLAN will hear that broadcast message. So we send the broadcast message from the blue VLAN, only the PCs on the blue VLAN heard that broadcast message. The red VLAN and the green VLAN, they didn't hear that message. VLANs are mutually isolated and packets can only pass between them via router. Like we said, blue VLAN to communicate with the red VLAN needs to go through the router. The partition of layer 2 networks take place inside layer 2 devices, usually via a switch, which means we can partition our ports in different VLANs on the layer 2 device, like a switch. PCs, they're not aware they belong to some VLAN. The host group of the VLAN are unaware of VLAN existence. Benefits of VLANs. First benefit is security. Groups that have sensitive data are separated from the rest of the network. Cost reduction. Cost saving results from reduced need for expensive network upgrades. Better performance, dividing flat layer 2 networks into multiple logical workgroups reduces unnecessary traffic on the network. Like we saw it, if one broadcast message comes from the blue VLAN, only the blue VLAN PCs are going to hear that broadcast message, not the red VLAN or green VLAN PCs. So we say shrink broadcast domain. Dividing a network into VLANs reduces the number of devices in the broadcast domain. And then we have improved IT staff efficiency. Easier to manage the network because usually users with similar network requirements share the same VLANs. We have different types of VLANs. So first type of VLAN is data VLAN. Data VLAN is the VLAN that is configured to carry user-generated traffic, normal data. A VLAN carrying voice or management traffic would not be part of the data VLAN. Then we have a default VLAN. All switch ports become a part of the default VLAN after the initial boot up of a switch loading the default configuration. The default VLAN on Cisco switches is VLAN 1. Then we have a native VLAN. A native VLAN is assigned to 802.1q trunk port. The 802.1q trunk port places untagged traffic on the native VLAN, which is by default VLAN 1. And then we have a management VLAN. Management VLAN is any VLAN configured to access the management capabilities of a switch. So VLAN 1 is by default the management VLAN. VLAN 1. So when we run the command show VLAN brief in a brand new switch, we can see that every port belongs to VLAN 1 by default. So the name of the VLAN is the default VLAN 1 active. So every switch has one VLAN by default, and every port belongs to that VLAN. The switches have 4 other VLANs, but they are not supported. So 1002, 1003, 1004 and 1005 are on the switch by default, but they are not supported or used. So VLAN 1, all ports assigned to VLAN 1 to forward data by default. Native VLAN is VLAN 1 by default. Management VLAN is on VLAN 1 by default. And VLAN 1 cannot be renamed or deleted. We cannot delete this VLAN and we cannot rename it. What is recommended is to move all ports from VLAN 1 and assign them to unused port, all unused port. The other ports, move them to the correct VLAN. So we leave VLAN 1 empty really. And especially management VLAN, we have to move it from VLAN 1. VLAN trunks. A VLAN trunks carries more than one VLAN. So VLAN trunks usually is between the 2 switches, and they do carry more than one VLAN. A VLAN trunk is usually established between switches, so same VLAN devices can communicate, even physically connected to different switches. A VLAN trunk is not associated to any VLANs, so they don't belong to one particular VLAN because they carry all VLAN. I don't want to say all VLAN, they carry VLANs, as many VLANs as you allow. Cisco iOS, we support IEEE 802.1q, which is a popular VLAN trunking protocol. So for example, here we have 3 VLANs on 2 switches. So the trunk is the port that is connecting those 2 switches together. For example, here we have red VLAN and a blue VLAN. They want to communicate. So here they have to go through the trunk. So this trunk cannot belong to one VLAN. It is belonging to all VLANs. So controlling broadcast domains with a VLAN. So VLANs can be used to limit the reach of broadcast frames. A VLAN is a broadcast domain on its own. A broadcast frame sent by a device in a specific VLAN is forwarded within that VLAN only. VLAN helps control the reach of broadcast frame and their impact on the network. Unicast and multicast frames are forwarded within the originating VLAN. Tagging Ethernet frames for VLAN identification. Frame tagging is a process of adding a VLAN identification header to the frame. It's like labeling them. So as soon as we get one new frame, the switches will label that frame to identify what VLAN the frame belongs to. It is used to properly transmit multiple VLAN frames through a trunk link. Switches tag frames to identify the VLAN to that they belong. Different tagging protocol exists. First is IEEE 802.1q, is a popular open standard protocol, And we have a Cisco proprietary protocol, which is ISL. The protocol defines the structure of tagging header added to the frames. Switches add the VLAN tags to the frame before placing them into the trunk links, and remove the tags before forwarding frames through the non-trunk ports. For example, we have again our little network here. As a frame coming from this PC on the red VLAN, it's untagged. The PCs, they don't understand, or they're not aware they are part of a certain VLAN. So as they come into the switch, they are untagged. They only get tagged once they arrive the switch. The switch will tag them. So it will tag him with the red VLAN, and they go to the second switch. The second switch will identify, okay, well, this frame belongs to the red VLAN, so I need to send it to this red VLAN here. But first I need to untag it, so I need to clear the tag before I send it. So again, this switch received the frame untagged. It's not aware that it's participating on some VLANs. Native VLANs and 802.1q tagging. Frames that belong to the native VLAN are not tagged, or so they're not colored. Frames received untagged remain untagged and are placed in the native VLAN when forwarded. If there are no ports associated to the native VLAN and no other trunk links, an untagged frame is dropped. In the Cisco switches, the native VLAN is VLAN 1 by default. So here, for example, native VLAN, in this case, we have made green VLAN. Green VLAN is our native VLAN here. So as a frame gets to the switch from the green port, the switch will say, okay, well, this is in my native port, so I'm not going to tag it. When it sends it to the second switch, the second switch will receive, okay, I'll receive a frame that is untagged. So since it's untagged, I'm going to send it to my native ports only. VLAN ranges on Catalyst switches. So on the Cisco Catalyst 2960s and 3560 series, switches supports over 4,000 VLANs. VLANs are split into two categories. First, we have a normal range VLANs, and then extended range VLANs. Normal range VLANs are numbered from 1 to 1005, while extended range VLANs are numbered from 1006 to 4096. The difference between two are that normal VLAN range is stored on the flash with the name VLAN.dat, so VLAN database, VLAN.dat in flash. Extended range VLANs are stored in configuration file in NVRAM. Normal range VLANs, VTP can only learn and store normal range VLANs, while VTP does not learn extended range VLANs. Creating a VLAN on a Cisco iOS commands, we first enter the global configuration mode by typing configure terminal. First, we can do that because we are in the privilege mode. After we do that, we create a VLAN with a VLAN ID number. So VLAN and then VLAN ID number. So VLAN 10, VLAN 20, and so on. Then we go to the VLAN configuration mode. We can see that has changed, config-VLAN. So we are inside the VLAN configuration mode, and we type name and we give a name. So VLAN, blue VLAN, for example. Here's a full example. So configure terminal, VLAN 10, name blue, and then end. Assigning a port to VLAN. To assign a port, first again we go to the global configuration mode. We type interface and then interface ID. So we enter the interface, for example, interface FA05. Once we're inside the interface configuration mode, we type switch port mode access. What this command does is says that this port is in access mode only. There's no another switch gonna connect to that port. It's the end device, like a PC. So to assign the port to the VLAN, we say switch port access, then VLAN number. What VLAN? Here's the full configuration. So interface FA05, for example, switch port mode access, switch port access VLAN 10. So here, what we're going to do is we're going to assign this PC on the blue VLAN. So VLAN 10, we're going to name it blue, and this PC is connected to port FA05. So first thing is we go to the global configuration mode. We create VLAN 10. In the VLAN 10, we name it blue. Then we go to exit and we go to the interface FA05. First thing we say switch port mode access, saying that this port is going to be an access port only. End device is going to connect to it, not another switch. And then switch port access VLAN 10. Switch port access VLAN 10 because we create the VLAN 10 here. To check the configuration, we do show VLAN brief, and we can see that now the port FA05 has moved away from VLAN 1, moved away to VLAN 10 here. So FA05 is inside the VLAN 10. Deleting VLAN. First thing we have to be careful when we delete the VLAN. Before we delete the VLAN, we must make sure that we reassign all member port to a different VLAN. If the port belongs to VLAN 10, for that example, FA05 belongs to VLAN 10, and we delete VLAN 10, FA05 will not be able to communicate with any other host until you move FA05 to active VLAN, or you create VLAN 10. To delete VLAN, you just say no VLAN 10. Trunk links. Now trunk links are between the two switches, yeah? So to carry the VLAN, different VLANs. First, to create the trunk link, we have to go to the global configuration mode. Once we're inside the global configuration mode, we access the specific interface configuration mode. And then we say switch port mode trunk. That's the command to make a trunk port. We can specify a native VLAN for untagged 802.1q trunk. So for example, switch port trunk native VLAN, we can make a VLAN 10. VLAN 1 is by default the native VLAN. We can just change it to VLAN 10. Specify the list of allowed VLANs to go on the trunk. For example, switch port trunk, allowed, VLAN, and then whatever VLANs you want to allow them. Configure IEEE 802.1q trunk links. So for example, FA024 here we have the port, and we want to configure this link to be our trunk link. So first thing we need to do is access the port FA024. It's connected between those two switches. Once we're inside that port, we say switch port mode trunk. We might get the command rejected error here. An interface whose trunk encapsulation is auto cannot be configured to trunk mode. So what is saying to you that we can't make it a trunk if we don't specify what encapsulation is using. We can have two, 802.1q or ISL. So we have to identify which encapsulation we are using. So by saying switch port trunk encapsulation .1q, or we could say ISL. .1q is preferred, open standard. After that we can say switch port mode trunk. The command will be accepted. So what we are doing, we are forcing this link to be the trunk link. And switch port trunk native, we changing the native from VLAN 1 to VLAN 10. By changing the native, we mean do not tag those, anything that comes in VLAN 10, don't tag them. Then switch port trunk allowed VLAN 1, we allowing VLAN 1, VLAN 10, VLAN 20, and VLAN 99. So for example, the VLAN 30 will not be allowed on the trunk link. So for example, if VLAN 30 comes to this switch, this port here will deny a VLAN 30 to flow on this trunk link. Now show interface FA024 switch port to identify that what we have done to check that configuration. First thing we have to find out is administrative mode, what we have set it as. We set this port to be a trunk. And then we're interested in here in operational mode. What is operating on? Is operating as a trunk link. Interface FA024, no switch port, trunk native VLAN 10, and no switch port trunk allowed VLAN 1, 10, 20, 99. It's to reset the trunk to default state, to how it was. Dynamic trunking protocol, or DTP. Now DTP, a switch port can be manually configured to form trunks. Switch ports can also be configured to negotiate and establish a trunk link with a connected peer. The DTP, or Dynamic Trunking Protocol, manages the trunk negotiation. The DTP is a Cisco proprietary protocol and is enabled by default in the Cisco Catalyst 2960s and 3560s switches. If the port on the neighbor switch is configured in the trunk mode that supports DTP, the DTP will manage the negotiation. The default DTP configuration for Cisco Catalyst switches at 2960s and 3560s is dynamic auto. Now there's few modes. So you can have switchboard mode dynamic auto. The mode can be dynamic desirable. The mode can be trunk or no negotiate. First mode enabled for us, you can have it dynamic auto. We can have it dynamic desirable, trunk, and no negotiate. So for example, if this mode is dynamic desirable, one side, this side of the switch, dynamic desirable, and this side of the switch is dynamic auto, the DTP messages, they're gonna go from the desirable mode into auto mode every 30 seconds. Remember, the DTP was a Cisco proprietary protocol which is trying to negotiate a trunk link between those two ports. So every 30 seconds, desirable mode sends the DTP messages. So if they keep going, the dynamic auto will say, okay, well fine, if you want to be a trunk, let's be a trunk. So if we set both sides to be dynamic auto, in the dynamic auto, the DTP messages, no one's going to send the DTP messages. Since nobody's sending the DTP messages, the link is going to be an access port. So by default, that's the default dynamic auto on 2960s and 3560s switches. So you have to make sure, if you want this port to be trunk, which we do in our case, make sure that one of the port is dynamic desirable or trunk. So first view we saw a dynamic desirable, the second was dynamic auto, and the third now we can force it to be trunk. But if we force it to be trunk, the DTP messages are still gonna flow, even though you force it to be trunk. So to stop those DTP messages, we say no negotiate. So remember that if both sides are set to auto, there's not going to be a trunk. The port is going to end up being access port. If one side is set to desirable and the other side is set to auto, then it's okay, because the DTP messages are going to flow from the desirable and it will end up being trunk. If both sides are set to desirable, then it's great. Both sides are going to send the DTP messages and it will end up being trunk. And you can force it to be trunk. If you force it to be trunk, then it's going to end up being trunk. If you do force it, make sure that you do no negotiate, so you can stop those unnecessary any more DTP messages. If missing VLANs, if all IP addresses mismatches have been solved, so you should have no problem with the subnetting, everything is done, but the devices that can still not connect or communicate with each other on the same VLAN, make sure that check if the VLAN exists in the switch. So no connection among devices in the same VLAN. First, you check, is the port in the correct VLAN? Show VLAN brief, for example. If it's not, assign the port to the correct VLAN. If it is, check the VLAN is present in the database. So again, show VLAN brief, make sure that the VLAN is in there. If it's not, create the VLAN in the database. If it is, there should be a verified connection among devices in the same VLAN. There should be a connection. Troubleshoot trunks. Native VLANs on local and peer ports match. If it's not, make sure that you change the native VLAN to match to the both switches. If it does, then trunk modes on local and peer ports compatible. If it's not, statically configure ports on both devices to trunk. If it is, then you should have operational should be trunk. Common problems with the trunks. Trunking issues are usually associated with incorrect configuration. The most common type of incorrect configurations would be native VLAN mismatches, trunk mode mismatches, and then allowed VLANs on the trunk. So if a trunk problem is detected, the best practice guidelines recommended to troubleshoot is in the order shown above. Okay, for this demonstration, I have a very small network. I have a PC1 on the left here that is going to belong to blue VLAN. And I have a PC2 that's on the right network that's going to belong to red VLAN. By default, all they are in the VLAN 1 and they should be able to ping each other. Then when we change the VLANs, they will not be able to ping to each other. So the IP address of the PC1 is 172.16.110. The IP address of PC2 is 172.16.120. The switch is 172.16.1.1 and the switch 2 is 172.16.1.2. There's no gateway here because it's only one local network. They will not be able to go to the remote networks. Okay, so first thing that I'm going to do is go to the PCs and assign the IP addresses. So to change address to the PC1 and give it a static IP address, we click Start, then click Control Panel here. After the control panel opens, select Network and Internet, Network and Sharing, change adapter settings. Right click on your network interface card, so right click there and select Properties. Select TCP IPv4, so properties of that, and the IP address that we want to give to it's 172.16.1.10, and the subnet mask is going to be 255.255.255.0. Press OK and close. We're going to do the same thing to PC2, so go to PC2. I already have a net interface card, so select the interface card, click Properties, TCP IPv4, click Properties, and use the following IP address. So I'm going to use 172 for this PC, 16.1.20, and the subnet mask 255.255.255.0. Click OK and close. To verify it, click Start and select or type CMD. Let's type ipconfig. I can see that my IP address is statically configured 172.16.1.20 with the correct subnet mask. I'll verify it on PC1 as well, so click Start and type CMD ipconfig. I can see the PC1 has got an IP address 172.16.1.10 and the subnet mask 255.255.255.0. For this exercise we don't need a default gateway. Okay, so I have two switches, switch 1 and switch 2. So I'm going to go to the switch 1 and assign IP address. This IP address is going to be assigned to the virtual interface, which is a virtual management interface. Okay, I'm in switch 1, I got switch 1 and switch 2. So switch 1, I'm just going to brand new switches, no configuration there, so click No here. Would you like to enter the initial configuration dialog and enable here config T hostname SW1, and I'm going to access that virtual interface. So interface VLAN 1. This is my virtual management interface. So IP address for this switch is 172.16.1.1 and /24 or 255.255.255.0. The virtual interfaces on the switch you have to do no shutdown. They are down by default. So end. Done. The switch 1 is configured. So I'm going to go to switch 2 now. So switch 2. No here. Okay. Once it comes up, we're going to change the name to SW2. So enable config T hostname SW2 and then access the virtual interface. So interface VLAN 1 IP address 172.16.1.2 and 255.255.255.0 and again no shutdown. End. Okay, these two switches, they don't have any for example any VLANs, so I can say show they don't have any configured VLANs. Show VLAN brief. You can see that we have VLAN 1 by default, VLAN 1, and all the ports, they belong to the VLAN 1 by default. We have 4 other VLANs, but these VLANs are unsupported, so we have all of them are unsupported. We have VLAN 1002, 1003, 1004 and 1005. These are FIDI and token ring VLANs not supported. So VLAN 1 by default we have it there, and all the ports that belong to the VLAN 1. VLAN 1 is our management VLAN. This VLAN we cannot delete or rename it. So what I'm going to do first is try and ping the neighbor switch, so switch 1. So ping 172.16.1.1. That's my neighboring switch. As you can see, there's a 4 exclamation marks, which means that we have received 4 replies. Now one of them has gone, but that didn't work because of ARP, or Address Resolution Protocol. So switch 1 and switch 2, they can communicate with each other. Say ping 172.16.1.2. So I'm pinging switch 2, and I can see the 100% success rate. So if I go to my PCs, so I'm going to PC 1 here, and see if I can ping the switch. So ping 172.16.1.1, and you can see that I have a reply from the switch 1. I ping the switch 2.1.2. I have reply from switch 2 as well, and I'm going to ping 172.16.1.20, which is PC2, and we have a reply from the PC2 as well. We will check that or verify it from PC2 as well. So I'll go to PC2 and say ping switch 1, ping 172.16.1.1. I have a reply, and ping 172.16.1.2, which is the second switch. I have a reply as well from there, and PC1, which is .10 in the end. So as you can see, there's a communication all around. We have a communication with each other because we all belong to one VLAN, or VLAN 1. This port here, we can see if it's trunking. So the command will be show interface trunk. Okay, so by default this port, or E00, which is port, is trunking, but it has encapsulation, it has chosen, or it has negotiated the ISL. So the port E00 is trunking, but it has chosen ISL. We do want that port to be trunking with encapsulation.1q. So if I say interface E00 switch port mode trunk, now I'm going to get that rejected command. So it says command rejected, and interface whose trunk encapsulation is auto cannot be configured as a trunk mode. So first you need to tell what encapsulation is it. So switch port trunk encapsulation.1q. That's what we want to use. Okay, now I can say switch port mode trunk. Okay, and to verify it, show interface trunk. We can see that the port, the trunking mode is on, and encapsulation is 802.1q, and the status is trunk. The native VLAN is 1. You can see the native VLAN. Remember, the native VLAN is not going to tag our traffic. The VLANs allowed on the trunk, they're all VLANs. We didn't disallow any VLANs. And active VLANs and allowed is only VLAN 1. They're by default. The pruning is not enabled at the moment. Okay, so if I go to switch 2 and I run the same command, show interface trunk, in here I can see the mode is desirable. You know, you had dynamic auto, dynamic desirable, we had a trunk, and no negotiate. This one has negotiated 802.1q and it's trunking, and port VLAN 1 is a native. So I can go to that port, so interface E00 switch port mode trunk, switch port mode trunk. As you can see here again, it's telling me that you can't have a trunk mode if the port is set to encapsulation auto. So first we have to tell what encapsulation. So switch port trunk encapsulation .1q, and then switch port mode trunk, and switch port trunk, and see the question mark, the mode. So here we can change what VLANs are allowed in our trunk, what kind of encapsulation there is, and we can say the native, what native mode we want. And then the pruning, we can enable pruning here. Pruning means that, okay, well, if I don't have any VLANs, any information for example, VLAN 99, don't send me in any data for that. Broadcast, unicast, anything for VLAN 99. When pruning is enabled, that's it. You will stop the neighboring switches for sending data for some VLAN they doesn't have. So it will say, okay, well, I have VLAN 1, 10, and 20. Send me the information for those VLANs. If you have any broadcast, anything for any other VLANs, don't send it to me. Okay, now end here and show interface trunk. We can see that at the moment the port E00 mode is on, so trunk is by default is forced. The encapsulation that we're using is 802.1q, and the status is trunk, the native VLAN 1. Or we can say show interface E00 switchboard. Here we can see the administrative mode switchboard is enabled. Administrative mode is trunk because we have manually forced it to be trunk, and the operational mode is actually trunking as well. So that's all we can use. So administrative mode says trunk, operational mode it says it's trunk as well. Okay, if I say show VLAN brief, you can see that we don't have any other VLANs. To create the VLANs, now what we did so far, before we create the VLANs, what we did so far, we made sure that this port between those two switches is trunking, and it's 802.1q the encapsulation is going to use. So it's going to use the native VLAN. So it's going to use the tagging. Now what we're going to do is create two VLANs, VLAN 10 and 20, blue for VLAN 10 and red for VLAN 20, and we do the same on switch 2. So first I'm going to go to switch 1, so access switch 1, and say config T, so to go to global configuration mode, and say VLAN 10. That's all you have to do. You can see that the mode has changed. We are inside the VLAN configuration mode, and here we can say a name, so name blue. Okay, we change the name and show VLAN brief. We can see that we have VLAN 10 config T again, VLAN to create another VLAN, so VLAN 20 for example. You can see the mode has changed again. Config, we are in VLAN configuration mode. If I put the question mark here, you can see the old configuration that you can do inside this VLAN. What we want to do is just change the name. Give it a name. So name red. Okay, and show VLAN brief. Okay, so here we have VLAN 1, which is by default, and all the ports are in the VLAN 1. And we create the VLAN 10 and VLAN 20. Now there's no ports to those VLANs yet. Let's just go and do it to the switch 2, same thing, and then we put this port on VLAN 10. Okay, so let's go to the switch 2 and say go to the global config, VLAN 10, name blue, exit, VLAN 20, name red, exit, exit again, show VLAN brief. This time you can see again I have VLAN 10 and 20 on this switch. If you enable the VTP, which you're going to learn later, if you enable the VTP, we'll actually do all this. We'll keep the VLAN databases synchronized. So if I go to switch 1 again, what I'm going to do now is I'm going to put this port on VLAN inside the VLAN 10. So port Ethernet 01 04/1, we're going to move it from VLAN 1 to VLAN 10. So what I'm going to do is move it from normal VLAN or default VLAN to VLAN blue VLAN. So E01 is going to the blue VLAN. Okay, so first thing to do is go to the global configuration mode, so config T, then access that interface. Interface is interface E01, and then first thing you need to do is tell that this is a access port and device is going to connect to it. So switch port mode access. Okay, that tells the switch that in this port there's going to be end device like a computer, laptop and so on, or server connected to it. There is not going to be a router or switch connected to it. Then we tell what VLAN to access. So switch port access VLAN 10. Okay, so what we did is moved the port from VLAN 1 to VLAN 10. So show VLAN brief again. You can see the port E01 has just moved from VLAN 1 to VLAN 10. It was VLAN 1 there. So we put these commands in, boom, this port has moved to VLAN 10. We will do the same on switch 2, where we're going to move this port into VLAN 20 by default. Let's move it. Let's go to config interface E01, switch port, mode access, and switch port access. I have too many C's there. Access VLAN 20. Okay, so show a VLAN brief. You can see that now the port 01 has moved from VLAN default VLAN 1 there into VLAN 20. Now these devices, the PC1 will not be able to communicate with the PC2 without the help of the router or layer 3 device. Now earlier we saw the PC1 and PC2 were able to communicate with each other. So if I go to PC1, we could see it earlier, the PC1 could ping the switch 1, so it could ping switch 1, it could ping switch 2, and it could ping the PC2. So let's see if we can do any of these now. Since we moved it from VLAN 1, we have moved it to VLAN 10. So ping 172.16.1.1, that's the switch 1. As you can see, it's having a problem pinging the switch 1. Okay, Control C to break this and ping 172.16.1.2, which is switch 2. And we can see that we have a problem pinging switch 2 as well. Control C again to break this operation, and then ping 172.16.1.20 is a PC2, and we can't ping PC2 either because it's on different VLAN. All of them are in different VLAN. So as you can see here, PC1 is on the blue VLAN. The VLAN 1 is the management VLAN for the switch 1 and switch 2, and the PC2 is on the red VLAN 20. So that's why this PC or PC1 cannot ping any of the other PCs. We will go to the PC2 and check the same thing. So PC2 could ping switch 1 here. It worked fine. We could ping switch 2, it worked all fine as well. And we could ping the PC1 as well. So let's just see. So ping 172.16.1.1, that's the switch 1, cannot ping the switch 1. Control C to break the operation. And switch 2, we can't ping switch 2 either. Okay, check that we can ping PC1, which is .10 in the end. We can't ping PC1 either. Change it to be on the same VLAN so we can see the communication is happening. If I go to the ports, so I'm now in switch 1, so I'm going to access the port that's connected to PC1, interface E01, and I'm going to do spanning tree port fast. So spanning tree port fast, what this command is going to do is going to make sure that the port is going to switch to forwarding mode automatically right away, rather than go through the 50 seconds wait. So we do the same thing for the switch 2. So I go to config T, interface E01, spanning tree port fast. Okay. Now what I'm going to do is switch from as you can see still, so show VLAN brief. You can see the PC2 that's connected to switch 2, it's on VLAN 20, and PC that's connected to switch 1, and show VLAN brief. PC that's connected to switch 1, it's on VLAN 10, as we can see it here from this picture. So what we're going to do is I'm going to start a long ping from PC2 to PC1, and then I'm going to go to switch 1 and I'm going to put this on the red VLAN, and we see the ping going through, and then move to the blue VLAN and see the ping are failing. That's the idea. So go to PC2 and start a long ping or continuous ping. Ping 172.16.1.10 minus T. It says continuous ping. Keep pinging. Right, so here, then I'm going to go to the switch 1. I'm just going to lower this down a little bit. and go to the port that's connected to PC1, so interface E01, and say switchboard mode. Well, we did say already access mode, so we don't have to do that. So just access VLAN 20. So once we access VLAN 20, we can see there we have a reply automatically. We had a long wait, 2000 milliseconds first one, but we can see that there's a reply. If I change the mode to VLAN 10, so switchboard access VLAN 10, the PC that cannot ping. It will time out. Right, so as you can see, if we are in the same VLAN, we can see that there is a communication, but if they are in different VLAN, there is no communication. There's a reply from itself. It says destination host unreachable, which means it's not working. So if I change it back to VLAN 20, they are in the same VLAN now. Now there is a VLAN, there is reply, there is pinging. If I change it back to VLAN 10, no communication. Okay, so if you want to separate your VLANs into partition into your network into different VLANs or virtual LANs, then those were the commands. Okay, we saw that when they are in the same VLAN, they was able to ping with each other, but when we put them in different VLAN, they were not able to ping with each other. First, they could ping the PC1, could ping switch 1, switch 2, PC2, and so on. Then we put on a different VLAN, was not able to ping any of the devices. So we did the same for PC2. First, it could ping. Then, when we changed the VLAN, it couldn't ping. Then what we did is make sure that first you can't ping the PC1 since it was in different VLAN. But when we changed the PC1 into red VLAN, we could see that there was a ping. Okay, thank you very much for watching. Please have a look at my other videos and don't forget to subscribe. This has been Astrid Krasniqi.